Okay, moving on to chapter 9 and talking about solutions. So, a dialysis nurse informs Michelle that her side effects are due to her body's inability to regulate the amount of water in her cells. And the amount of water in her body fluids is regulated by the concentration of electrolytes and the rate at which waste products are removed from her body. So, what are solutions? Solutions are homogeneous mixtures of two or more substances that form when there is sufficient attraction between the solute and the solvent molecules. They also have two components, the solvent, which is present in a much larger amount, and the solute, which is present in a smaller amount. So what we're going to do is we're going to learn to identify the solute and the solvent in a solution. And we're going to be able to describe the formation of that solution. So an example over here, the solute is the substance that's present in the lesser amount, okay, which would be the salt, where the solvent is the substance which is present in a greater amount. So solutes may be liquids, gases, or solids, and they are spread evenly throughout the solution. They're mixed with solvents, so that the solute and the solvent have the same physical state, and they cannot be separated by filtration, but they can be separated by evaporation. They're not visible, but they can give color to a solution. All right, so for example, here, a solution of copper 2 sulfate, which is CuSO4, forms as particles of solute dissolve and become evenly dispersed among the solvent water molecules. So you can see here, it goes from clear to a blue color. So here is a handy dandy little summary table of types of solutes and solvents. Okay, so refer back to this when we need to know. Okay, so let's talk about one of the biggest solvents, and this is water. So water is one of the most common solvents in nature. It is a polar molecule because of the polar oxygen to hydrogen bonds. And the molecules form hydrogen bonds, and these are important in many biological compounds. So you can see here that we have the partial negative charge on the oxygen and the partial positive charge on the hydrogen, and these are having our hydrogen bonds sticking them together. All right, so we have a formation of solutions. Solutions form when the solute-solvent interactions are large enough to overcome the solute-solute interactions and the solvent-solvent interactions. So again, handy dandy label, like dissolves like. So solutions will form when the solute and solvent have similar polarities. Again, like dissolves like. So solutions will form when the solute and solvent are like, but they will not form when they are not alike. Okay? So talking about this in solutions with ionic solutes. Sodium chloride crystals undergo hydration as water molecules surround each ion and pull it into a solution. So when we have solid salt and we add water, it's going to separate and we can like dissolve it, right? And so that is through a hydrolysis reaction, right? Because we're adding water. So it's going to separate out those different ions so that we can make a solution. So solutions with polar solutes. A polar molecular compound such as methanol, which is CH3OH, is soluble in water because methanol has a polar OH group to form hydrogen bonds with water. Polar solutes require polar solvents for a solution to form. So here we have methanol and we have water, and when they mix, because they're two likes, we're going to have a methanol water solution with hydrogen bonds. All right, so let's apply. So let's identify the solute in each of the following solutions. If we have 2 grams of sugar and 100 milliliters of water, or 60 milliliters of ethyl alcohol and 30 milliliters of methyl alcohol, for C, we have 55 milliliters water, 1.5 grams of sodium chloride, and for D, we have 200 milliliters of oxygen and 800 milliliters of nitrogen. Pause me and come back. All right, so for this one, we have the solute is sugar, it's much bigger. Okay, for B, the solute is methyl alcohol. Okay. For C, the solute is sodium chloride. And for D, the solute is oxygen. Great job. All right, let's try again. So when we have a solid lithium chloride is added to water, it dissolves because why? Pause and come back. So for A, it would be because the oxygen atom of the water is, the lithium ions are attracted to the oxygen atom of the water, where for B, it would be because the chlorine ions are attracted to the hydrogen atom of the water. Great job. Let's try this again. So with the following solutes, will they dissolve in water and why? Okay, pause me and come back. Okay, for A, Na2SO4, it will dissolve because it's ionic. For gasoline or nonpolar, it will not dissolve because it's nonpolar. For I2, it will not dissolve because it's nonpolar. For HCl, it will dissolve because it's polar. All right, good job, guys.